Hey guys, so it's the final video of our video project that we have been doing for the whole semester. Let's see what we have here. At the selection stage of the project, I have wandered around the city to find some structures that have caught my attention, like this newspaper stand. But finally, I chose this abandoned service center at Burney Station because I passed by it every day and it is kind of interesting to me. I took pictures from different angles and approximated its dimensions. And in this project, we are going to analyze two beams which are AB and BC as shown here. So let's get started, shall we? This is what we did in task 2. For beam AB, we assume there is a uniformly distributed load across the beam, and for beam BC, we assume there is a point load at the middle pointing downwards. Both ends are supported by a pin and a roller respectively. After the calculations, SFD and BMD are obtained, which show how the shear force and bending moments vary along the beam. Then our task 3 starts with beam AB. The first thing is calculating the maximum bending stress. Using this formula for the assumed cross-sectional area on the right-hand side, the sigma maximum is 4.85 megapascal. The second thing is the maximum shear stress, which is found to be 0.539 megapascal by the formula. Then we come to stress transformation. According to the graphs, we have two information. First, when we use sigma y is 0 and tau is 0. When we use tau, and the second is when we use tau, sigma x and y are all 0. We are using them to find the following data. For the following data, for the maximum principal stress and planes, we use the first condition and sigma maximum is 4.85 and theta p is 0 or 90 degree. And for the in-plane ones, we use the second condition. Tau is plus or minus 0.539 megapascal and theta s is also 0 or 90 degree. From the results, the possible failure planes may appear at the middle of AB at an angle of 0 or 90 degree. After that is the maximum deflection and slopes. We use different boundary conditions to find the constants in the formula of deflection and slope. Finally, we find that the maximum slopes are at point A and B, which are plus or minus 0.661 degree, while the maximum deflection occurs at the middle, which is minus 6.488 times 10 to the power minus 3 meter. And these are all the calculations for beam AB. And for beam BC, because we assume the cross-section area is the same, so the only difference is the value substituted to the formula. And here are the detailed calculations which are quite similar to those in AB. To sum up the results we get, the first thing is both of the beams may have failure planes at the middle of them in a degree of 0 or 90 degree. The second thing is beam AB generally experiences a higher value of all the stresses and deflections. And that's all for my video project. Hope you enjoy it.